Hi, and welcome to Module 2 of the Senior Maths B Professional Development modules. In this second module, we're going to be looking at planning as the area alongside some of the content. In this brief lecture on planning, I just want to talk about some principles about planning as they relate to senior maths. Now, I know from what you've posted on the discussion board about your background that you're already teachers who have a lot of experience in many cases of teaching junior maths or other subject areas, and so planning is something that's not new to you. You already know how to plan, you've planned in other contexts, in other ways, and so I'm not trying to tell you how to start again to plan when you already know. But we also know that in planning, it's not that hard in senior maths to plan a lesson where if you're going to give them some notes and some examples, then work through a couple of worked problems on the board and then get them to work from the textbook. You can probably do that already without too much advice from me. Also, I'm not saying this isn't an important standard type lesson to have, but if that's all you have, then the program's going to be a bit malnourished. So how is planning in senior maths different? Well, first of all, it's conceptually dense. In senior maths, there are a lot of ideas that are really conceptually tricky and have a lot of issues in them when you try and come to understand them. And so sometimes we can reduce them to being conceptually simple but procedural in nature. And that can be a problem because the kids might be able to do all sorts of mathematical procedures, but they don't really understand what they're doing. So because it is conceptually dense, that can make planning difficult from other areas or junior areas, and it also has to be considered when you do your planning. The second thing about senior maths is, unfortunately, it's pretty content heavy, and particularly as we move into the Australian maths curriculum in a couple of years, it's even more so. There's a lot of content. So there can be a real pressure on time to race through things, and sometimes we skip the kids' understanding in order to just finish the program that we have in front of us. So as we think about planning in general, it's important to remember that planning still needs to be learning driven and focused on what the students are learning and what they can do. Now again, I'm not going to repeat all the principles of good planning that you already know, but in senior maths, it's important that conceptual development comes before practice. So for example, if you want them to develop an understanding of a topic, something like trigonometry for example, it's important that they understand that trigonometry is about the ratio of the sides of a triangle before they race into doing things about sine, cosine and tan, or even reducing it to what a lot of students say, SOHCAHTOA. They need that conceptual understanding and that appreciation for what they're doing before they then go and practice something. Because as we've talked about previously, practice doesn't make perfect, practice makes permanent. Now, practice is a good thing once they have that conceptual level of understanding. The other thing about planning I think is important is often in our plans we plan all the activities we're going to do, and it has like a good program of exercises or activities and tasks, but we don't always plan the learning around it. And as teachers, most of the times we try and promote learning and facilitate learning is through asking questions. So maybe sometimes it is worthwhile to think about the questions we'll ask and the way we'll try and promote understanding by asking good questions rather than just doing them off the top of our head. So planning involves preparing a good sequence of activities, asking good questions, but also preparing yourself as a person who knows and understands the mathematics. And in this 16-week program, we've got lots of time spent on the content areas, and although it's a little difficult to support that at a distance, we're hoping you'll be able to work through some of those exercises as part of your planning to be a good maths senior teacher. Now what I've got here is a small way of thinking about planning. Often if we look through the way exercises are structured in textbooks, they start with the top ellipse there where it says mathematical concepts or ideas. So we develop the mathematical concepts or ideas, and then towards the end we try and get the students to apply them in some sort of context. If you look through an exercise, there might be 15 problems in an exercise, and the first 12 will be basically exercises where they're just practicing the skills, and then you'll get to question 13 and it'll say something like, if a train's driving 50 kilometres an hour to the east and another train is travelling 40 kilometres, or some sort of word problem like that. And the kids find them quite hard because although we can see the connection between the mathematical concepts and ideas and the application, it's not always that obvious to the students. So as part of our planning, it's important that we help them see that. Now I'm suggesting often a good way to do that is to start with the problem in context first, as I've got in the ellipse there under the word generalise. Start with a problem in context and then generalise the mathematical concepts or ideas out of that, and then help them to apply that in other context. If they can see it from one context, then they're more likely to be able to apply it to another context. And also it gets past that question of when am I ever going to use this, because we're starting with some place where it's realistically used. So for an example, it might be as simple as when you're starting a unit on parabolas or 2D motion or calculus, you might start by simply tossing a ball back and forth. That might not always be possible in the classroom, so maybe you need to go outside. But just looking at the motion of the ball as it is tossed from one person to the other, and then developing an understanding of that through some sort of guided discussion. So how could we describe this form of two-dimensional motion? Why would it be an advantage to use vectors or calculus or whatever's relevant at the time? How can we use those to predict the acceleration and those sorts of things? And then once we've done that work, then it's time to then consolidate through some practice through things like textbook exercises. Now that part of planning is quite difficult and takes a lot of time, and sometimes the problem is undertaking those activities can be seen taking too much time away from the time for the important or so-called important work in the classroom of doing the exercises. But if we can find simple but meaningful tasks that help the students to get a conceptual understanding first and start our planning with that, then move into the more practicing type tasks with exercise and things like that, then maybe we'll get some better results from the kids. At the end, once we've gone through those things in our planning, then of course it's time to revisit these sorts of things. And in fact, I think it's probably important sometimes when we get to the end that we revisit some of the things we've done even a little while ago, so the students don't get things compartmentalised into small boxes or different ideas and see that they're unrelated. Now I want to give you an example of how we could start some sort of planning like this. This is just a small example, but it's called the nest egg, and I'm going to show you something that I collected a long time ago. So this here is a page out of the newspaper, and this was published on Tuesday, November the 22nd in 1986, my first year teaching. And I collected it, and it was about nest eggs in retirement. And you can see they've used different size eggs here. Now, I then used this as a starting discussion around areas and volumes and what they might represent in terms of the depreciation of our nest eggs, or the appreciation if we invest in superannuation. The beauty of having this kept from 1986 is it talks about different dates in the article, in the advertisement, which you can't see obviously, and we can look back and say, well, how did this work out? Is this true? And there's a whole pile of mathematics we could then plan around that. Incidentally, at the same time, this ad came out, and I've placed a copy of this in the Learning at Griffith site. But I never kept the original of this, I just photocopied it, and I wish I'd kept the original because it just makes the activity a bit more authentic. But you can see from these sorts of activities we can create a whole range of mathematical activities which have deep conceptual knowledge but realistic applications that they might see in everyday life. I'm just including this as an example of where we might get a start of something we could use for our planning. Now, in this week's session for the program. The last thing we've got is a planning task. And what we're hoping you might do is plan up some sort of activity. It might be something based on something like the nest egg that I just showed you, or it could be something else. We're not really looking for just a standard exposition, worked example, textbook exercise plan, but something different. And if you develop it, I'm suggesting, first of all, it might be good that you can share it. And I've created a folder on the discussion board where you can put it with a brief description. And if you put one in, then you're welcome to take the copy of someone else's that's there. And that way you might build up a bank of activities. If you don't put anything in, then don't take anything out. The other thing is, I know from your discussion board posts about your introduction, a lot of you are based all around different parts of Queensland. And a lot of you are working on your own. So if you want some feedback on your plan, if you email it to the address that's there, and it's also in the Learning at Griffith site, then Phil will have a look at it and he'll give you some feedback on it as well. So I hope that's useful. Again, in this week, I'm not really going over all the basic planning things that you can already do. I'm just trying to find some different ways you might think about planning in senior maths and some of the things that might enhance the students' conceptual understanding. All the best.